later.
Sorry, now we're recording it.
Now we're recording it.
Did I just minimize?
Yes. Okay.
Okay, now the problem is, how do I close this down?
Can you escape?
Okay. Thanks for joining, everyone. As Kelly mentioned, I'm Monica Noon. So I'm just going to first start on kind of giving a background of what the Resilience Atlas is. We've realized that a lot of people don't really know what the Resilience Atlas is at CI. So we just wanted to highlight that before we go into the Sparc Visualizer, which is a new capability that we added under the Sparc Project. So if you go to resilienceatlas.org, you'll go to our homepage here. There's a couple of options in the top right, going through journeys, which steps through the way we like to view data and kind of give insights around some of the different things we've discovered through data sets that are available within the Resilience Atlas. We'll be talking mostly about the map today, but I just wanted to highlight that there are more than one atlases. So we have hired a consultant, a contractor, Visuality, to develop this. This was developed in 2015, so it's actually 4 years old now. And originally we just had one global atlas, but what they did was they created something that we could create different atlases, and we can add data sets. So it's a complete platform where we can curate data layers, the design, logo, branding, everything on our own. So it's a CI owned. All the code base is open source, so we have the ability to, like I said, manipulate things as we need. So some examples of atlases that we've created. We have a few Jeff-funded projects, Trends.Earth, of course. This is one way that we disseminate the outputs of Trends.Earth. So Trends.Earth, of course, is a plugin to QGIS, which is an analytical tool, but we realize that a lot of people do not have maybe GIS skills, they don't have the software, so this is one way that we can kind of publicize global outputs in a browser-based atlas. We also have a food security project that's actively underway. We're in the second year. That's through the African Field Division, also funded by the Jeff, piloting with 12 different African countries, monitoring their food security with different interventions over a 5-year period. We have some country atlases, and they have been created for a couple of different reasons. So for Madagascar and South Africa, we actually created that for a policy discussion around where we can identify entry points for EVA projects and how we can integrate those into national adaptation plans. So we created these national level atlases a few years ago when those discussions were underway. We also had some work looking at sustainable agriculture, livelihood, and conservation projects to help identify a donor in Ethiopia and DRC. And we have created also one for Indonesia, just for other discussions in the region. We have an atlas for each vital signs country, which highlights some of that data. We also have some regional atlases that we're planning on building on. One that I wanted to highlight is the Asia Atlas. We currently are working with a researcher at the University of Adelaide who is building the Asia Pacific priority setting tool. So that will be something that will have an interactive database for modeling and prioritizing in the region. Recently we added pad data to an atlas as well, so you can find all pad data there. So when you click on maps, I've just added new tabs just so we don't have to wait for it to load, which usually is not a problem. You can see this is just the global atlas. So this is the original design that we've created. Patrick will go into more detail in a few minutes on the Sparc Visualizer, but you can see here in this layers panel, we have different categories. So this is just how we thought that data layers could be arranged so they're more easy to use by users. So when we were originally creating this project, Rockefeller Foundation funded the original design and construction of this atlas. in this platform, they didn't want us to do an analysis that was static, that could easily be outdated, on like an analysis on resilience, because they wanted to know where they could invest in resilience projects, and what they wanted was something that was usable, that could be updated, that users can explore data sets and overlay, just with simple basic overlays in order to explore how these data sets can help inform them on situations on the ground. And like I said, again, not everyone has access to a GIS software, and they don't have maybe the skills to use the software, and especially it's very time consuming to find these data sets. There may be same data sets that have different levels of relevance. So we've concentrated everything into this one area so that you can easily explore different data sets that we find define resilience. So we have these three major categories: livelihood, production systems, and ecosystems, stressors and shocks, and factors influencing vulnerability. So the way that we've kind of guided users in the journeys section of our website is having somebody look at maybe a geography or a theme that they're interested in, and looking at what type of exposure of the system has in an area of interest to certain stressors and shocks. So if I can drive this with this little pad, an example that I like to show is coffee. So way down at the bottom of this list, we have where coffee is grown. So if we look at Africa, we can see areas where Arabica coffee is grown. And we can look at something like temperature. So coffee's, like the production of coffee is impacted by minimum temperatures. So we can go ahead and overlay those two layers and see where we're seeing the trend of mean daily minimum temperature increase, and how that could potentially impact coffee in certain areas, especially here in like Rwanda, Burundi. We're seeing like higher production of coffee throughout the country, and we're seeing a potential increase, or this is actually historical increase of minimum daily temperature. So that could potentially impact coffee growing in those regions. And then you could look at different parameters for example, where women are without access to mass media. So if you were planning an intervention, how you would reach out to women growing coffee in these areas. Now you'll see that we can actually change the transparency so we can see a little bit better what's underneath there. So we can see again these socioeconomic variables for ways to reach out to maybe female farmers in those areas. And then we can toggle on and off those different layers so we can isolate where maybe an intervention could be made in places where we work. So that's one option of turning on and off layers, as well as turning up and down transparencies. You can also look at the information for every layer by clicking on the eye to get the description of the data set, the source, and the link to that data set. So it's just a really good way for CI to also showcase some of the data sets and products that we produce. We have one from biodiversity hotspots. So you'll notice next to this has an additional icon where you can actually download that entire global layer from the atlas. So this just allows us to have a platform where you can overlay with different data sets that aren't created by CI, but also to kind of house our spatial data layers that we can then disseminate through being available for download, as well as just getting a bit more communication around those data sets. So like I said, this was created in 2015. We have done some minor upgrades since then, but one of the most major upgrades has been under the Sparc Project. So we've upgraded everything on the back end to improve some of the efficiencies. Of course, technology changes over time. We've also kind of improved some of the features, like the analysis feature. Last year, we added a predictive modeling feature. So we have an example in Ethiopia for agricultural intensification of maize. Oops, I can click on it. So we have different parameters that are usually used for understanding where you can intensify a crop. But of course, as a conservation organization, we also want to consider natural capital, where forest areas exist, where protected areas are, because we don't want people intensifying crops in places where they're currently under protection. So we can change these sliders and increase them based on what we find important and imply that, and that will produce an output modeling all the different layers together. So that again is what the researcher at the University of Adelaide will be working on for Asia Pacific priority setting. So now I will turn it over to Patrick, who will go through a few slides, and then we'll do the demo of the Sparc Visualizer. There.
Great, thanks, Monica. Can everybody hear me okay?
Yes.
My network keeps saying it's not great, so hopefully this goes through. Okay, so just a real quick rundown of what we're going to be looking at in the visualizer, just so we have some understanding of what the data we're manipulating is. So the Sparc Project is that acronym on the screen. It ends today. It's the end of a 3-year project, so I have lots of reports to submit later today. If you can advance, Monica. Working with global partners, funded by the GEF, 3 continental size assessments running across the tropics, with all those institutions on the screen as primary partners, with many more as sub-grantees. If you can advance, please. And the crux of the project is we are looking for areas where you might want to put or consider conserving to maximize representation of species and ecosystems as they move and adapt to climate change. The figure on the screen is just an illustration of an observed phenomenon of montane bird species moving upslope, as you might expect, as climate has been warming over the past 30 years. So taking these individual observations and scaling it up over many thousands of species over a continental domain using various species modeling techniques, we're able to produce some prioritizations for areas that are most valuable for additional conservation under climate change. If you can advance 2 slides, Monica, that's great. One more, please. Okay, so the data we'll be looking at today is derived from the same information that you see on the screen now. So what's on the screen now is the priority for all species, all plant and animal species that we're able to model in the neotropics. For the neotropics, that was close to 50,000. And the successive shades of green are higher value or greater priority for areas to add to the existing conserved area network. So areas in darkest green are the most valuable spots of the landscape to conserve all species, both current ranges and future ranges simultaneously. So there's a couple ways to display this. One is to display it from a continental perspective. So if we were to do that, the Andes and parts of Mesoamerica would light up very highly, whereas some of the other countries may not be as much, just by virtue of the background biodiversity. But the way that we've displayed it in this map now, and the way that we're going to look at it in the visualizer, is rescaling that solution within each country. So if you look at just Peru, those areas in Peru are the most important areas for Peru by itself. And likewise for all the other countries we analyze. And the reason for doing that is, again, just a lot of planning decisions are made country by country, and not necessarily from a continental or global perspective. So again, this is all the data we'll be looking at in the visualizer is the same information that's depicted on the screen right now. So the disadvantage of showing it in a static map like we have right now is it involves choices of color amps and thresholds, which we determined to tell our story. But the actual solution, every single pixel in the domain, it has a value. So if the potential user wanted to see a smaller area of conservation priority, this map, they could look at the top and the green in this map, but it's harder to see if they wanted complete control over exploring the full range of possible conservation actions. So that's what we had in mind in developing the visualizer. So the next couple slides, Monica, you can run through quickly just to demonstrate we've done this over the 3 continents, but it's all the same type of data. And then I think we can move on to the demo in the visualizer. Oh, so in addition to continental scale runs, we did focal regional assessment runs that were at finer resolution with species that were endemic to those focal regions. But the information we're looking at for this demo today is the continental scale runs. Okay, I think we're ready for the demo. So I think Monica is going to start with the solution for Southeast Asia. Again, this is housed under the Sparc Visualizer drop-down menu in the Resilience Atlas. Okay, so Monica just turned on the priority for the Indomalayan tropics. So everything in blue there is the entire solution domain. The zonation solution was not allowed to go into areas that were intensively agriculture or urban. So areas that are not blue right now were not part of the original solution. So that's if you wanted to conserve everything that's available, that's up there right now. Of course, that's not what you necessarily want to look at. So Monica's hovering over the little graph at the bottom right, which the x-axis on that graph is the total area in terms of percentage terrestrial area. And the y-axis is the total carbon stock that's also within that same area. So Monica's on roughly 29% area right now. So the areas in blue are what every country would need to do individually to achieve that 29% terrestrial area coverage using the priorities from the zonation solution. So some countries have lots of existing protected area coverage, so less blue is showing right now. Other countries aren't close to 30%, so there's much more action required to achieve that target. And Monica is showing that you can move that terrestrial area target up and down. So she's at 47-ish right now. If you can move down to like something.
I think we lost you, Patrick.
Patrick, can you hear us? You did mention having bandwidth issues earlier.
So how is that, can I ask a question? How is that calculated? Because, there's infinite ways in which you can add up these polygons to get up to 20%.
Am I back?
Oh,
Yes, you're back,
yes.
yeah.
Okay. I don't know when I went away, but I don't know.
I think as Monica was demonstrating on the slider, different threshold options, and then Jorge had a question. I don't know if you were able to hear that or not. And if you're still with us.
Text him again. So your question was, how is that actually calculated? Right.
Yeah, what configuration do you choose? Because there's, infinite possibilities.
It takes and obviously Patrick's the best one to answer, but you take the existing PI network as a given first, so you're not altering that. And then you're running across hundreds of thousands of species, and they're using zonation as the technique they're actually using to maximize basically the benefit of each additional unit that you're adding to your network. But it's taking into account connectivity with the existing protected area network and anything that's been added at lower levels of priority. So basically you're building it up with that.
Okay, so there's a lot of constraints on how you do that.
Yeah.
You just impose.
Yeah, so I caught the tail end of that, and that sounded exactly right, Alex.
Okay.
And there are lots of methodological choices we made, which would take a separate webinar, I think. But the basic gist is, every species that we were able to model the zonation solution finds the most valuable areas to represent both current and modeled future ranges. And then, again, this is across 10 different climate scenarios, and the dispersal limited overlap between those two. So it's really trying to emphasize potential future ranges that are possibly reachable by a species' capacity to respond to climate change. And Alex is right that the initial protected area system was taken into account first. So the job that existing protected areas are doing, that's explicitly accounted for first before then the rest of the solution, the rest of the priorities are determined.
Cool. Okay, thanks. All right.
Okay, great. So we have the continental solution, which Monica has been showing so far, and the resource curve at the bottom right was showing the trade-off or the efficiency curve between the served and the total amount of carbon that comes along with it. We also disaggregated that by country because, you know, if you're from Thailand, you may not care what the continental resource efficiency curve is. You want to know what's going on in Thailand. So on the screen now is the same solution area for Thailand. There was something weird with the protected area in Thailand, so that little blue area in the middle is actually protected. So we'll need to clean that up a little bit. But Thailand has currently about 22% protected area coverage. So the solution here in the bottom right starts at about 22, 25, somewhere in there. Yeah, so that's where the solution starts. And much of Thailand is intensive agriculture. So that when you see that plateau on that efficiency curve in the bottom, you know, that's occupying the entire available space. And by available, it's just areas that are not agricultural or urban. But same functionality with this. You can play around with solution, explore, you know, what are the most valuable, you know, top 1% pixels, all the way up to the complete solution, and then what the associated carbon benefit is, along with conserving those additional areas that are shown here in blue. Why don't we turn on the carbon layer just so we can see how that's looking. And so the Sparc Visualizer, so the demo today is focusing on just this co-benefits with carbon, but the capacity is to juxtapose these priorities with any other, you know, base layers people are interested in analyzing, and it's a very relatively simple process for us to generate those efficiency curves based on the Sparc priorities. Okay, so on the screen now is the total carbon stock that's based on above ground biomass plus soil carbon. I think the color, right? Yeah, so the lighter orange is more dense carbon, and the brown is less total carbon. And it looks like Monica is pulling up the Thailand boundary from the drop-down menu. So she's running through the analysis. So the Thailand boundary, you know, it's a simplified boundary, obviously, but it gives you an idea. And then the analyzer will, you know, look at the layer you're analyzing, in this case carbon, and generate some quick summary statistics. I say quick, but it looks like it's still spinning. But the summary statistics are just, you know, the mean, max, the sum, standard deviation of, you know, in this case carbon, whatever layer you're interested in analyzing for this country boundary. And once that's done calculating, it's usually much quicker than this. You can download the results for your own purposes. And is my screen frozen, or is it just not going, Monica?
No, yeah, it doesn't seem like it's doing anything, even though I tested it.
Okay.
20 minutes ago.
Here we go.
There it is.
Oh, there it goes. So that's what it looks like at the end. Okay, so you get a histogram, it give you a sense for the distribution and some basic summary statistics, you know, just to wrap your head around, you know, what's going on, you know, within national boundary. Or if you wanted to be more user-defined, you can actually draw your own polygon that you're interested in analyzing, just freehand. or you can upload a GeoJSON polygon file to do the calculations for you in your region of interest. Okay, so Monica's drawing a little polygon in Thailand, and the analysis should do the same thing. Yep, there it is. So again, so we have carbon loaded up for this demonstration today, but we'll also be porting over all of the biodiversity layers that Sparc has produced, both current and modeled future, in terms of both species richness and other biodiversity metrics. So all this will be shortly available to explore ad nauseum.
What's the x-axis on those?
Again, so you can.
I think they need to swap the axes.
Yeah.
Yeah.
What's what there?
Because it should be frequency on
Should
the
be the
Y,
frequency.
carbon on the.
Yeah.
Ah, okay.
Yeah, so it needs to be flipped. All right. That. Yeah, and then, so then you'll also be able to download that as well as the clipped layer to whatever you've run your analysis on. And then just, if you forget what layer that is, because you've collapsed that layers menu, you can see again the information from that data layer. And download a report, which will show all of this in a PDF.
Competing with you, Jorge, for visuality's time, I think.
Sorry, we're.
I'm very tired of this.
That's what I was going to say. I don't think they're going to be able to do anything for the next 2 months.
We're almost done.
Okay. So this carbon layer, is that a static carbon layer?
Yes.
Yeah, okay.
Right, that's just from Bacini, right?
I think it's Abitable.
Oh, sorry, table. Yeah.
It's habitable plus soil grids.
Which is what, 2000?
I think it's.
Soil grids information was.
Soil grid is sort of.
Oh,
whatever
soil grids,
date
yeah.
you want.
Oh, it's Abitable and soil grids.
Okay.
Right, added up for carbon stocks. So that won't change for a while.
It's like 2015 or something.
Well, it brings in data going
For
from like
30
the 60s.
years? Yeah.
I mean, they've
Oh,
got soil
like
profiles
composites.
from, yeah, a long time. So we call it
Cool.
2000.
Right.
So Patrick, is there a way to look at particular species of interest, or like what if you just want to know like birds, and what are the more important places for birds?
It's certainly possible. We have not uploaded all those disaggregated donation solutions into this visualizer yet. Sort of this balance of accessibility, like we can't have too many things in the drop down. But if that's something folks are especially interested in, we can certainly make a push to have those disaggregated by taxa solutions up there as well. But kind of our default priorities that we've been presenting to stakeholders is the combined priorities with both vertebrates and plants. And so that's what we have. It's kind of our first, or our best foot forward on the visualizer.
And Patrick, there will be.
But in terms of individual species,
Oh, go ahead.
Go ahead. I'm sorry.
I
I was just going to say the individual species models will be accessible from the BN database. So we've been partnering with the group based in Arizona to do a lot of our bulk species modeling, and they will be hosting both the occurrence records database and the species range models for both the current and future projections. And that's a good topic for a future webinar.
Noted.
And Patrick, there will be, you've done a comparison outside of just carbon, right? So there'll be priority based on other like base layers that you're comparing?
Right, so the priorities themselves are just based on the biodiversity information. So the carbon demonstration here is to juxtapose what those priorities look like against something else of interest. So what we have in the bag is what we're seeing now, but certainly we have all the calculations done for it's species representation under different levels of priority, and it's a very quick analysis on my end if there's other co-benefit layers that folks are interested in having as available on the visualizer, or just for their own personal edification.
What's the best way to give you feedback on what people would like to see, I guess, as we're moving forward?
Just hit me up on email. I think that's probably the best way. I mean, so the rest of the day and probably next week, I'm closing up Sparc, so I'm closing the bandwidth to address any any such requests. But certainly looking forward to building this out in the weeks and months to come with additional data that folks find useful.
All right, well, it looks like we've already transitioned into the question period, but if anyone that's joining us online wants to ask a question, you can either unmute yourself, or I'm also monitoring the chat window. And then do we have any other questions here in the room? Giacomo, do you want to start us off?
Okay. Thank you so much, Patrick. It's very nice to see it in the Resilience Atlas. So we don't ask you every time this country and this other country. And then my question was, like, in the presentation, you showed the different priorities, 3 different priorities with different colors. Is it that what we can do now with the graphic? Or how were those chosen? I'm not so sure.
Right, so in the maps that I showed before, the 3 different colors were essentially the top 10, 20, and 30% priorities, and that was really just to show draw the eye to the most valuable pixels, and not show absolutely everything is a priority. So it's focusing on achieving for every country to achieve the top 30% of their terrestrial area coverage. But and as you point out, that was a choice that we made for that static map. So that's the benefit of having it interactive in Visualizer, so you can see what it looks like if you only want to do the top 10%, or if you want to do up to 50%, what those areas are based on the same information that goes into those static maps. Did that answer the question?
Yes, thank you.
Okay, great.
So Patrick, another question.
And we did explore.
Oh, go ahead.
Oh, go ahead. I was saying we did explore the possibility of having something. We're looking at just blue right now, but having something gradational in how this is viewed here. But the initial feedback from Visuality was that would be too hard. So this is what we have at the moment. But it's possible that we could further emphasize the top priority pixels in this interactive layer as well.
So a couple of questions for you guys as you were looking at, obviously, the existing protected area network, which presumably is going to be updated with each iteration of the WDPA or other data sources, as well as agriculture and what was it, urban areas, I think, which will also be continually updated. Was land tenure a part at all, or a consideration at all for what we're seeing here?
Only in the respect of what you just mentioned. So okay. Protected areas, conserved areas were solved separately in the whole solution, and in our initial runs we did have some more sophisticated downweighting of areas that were agricultural or urban, but that tended to produce some counterintuitive results because it was artificially making some species much more rare and actually put some huge priorities like smack in the middle of Bangkok, which didn't make a ton of sense. So we really kind of simplified the domain of the solution to only the areas that are not intensive agriculture or strictly urban. But there's certainly, I mean, there's plenty of room for further customization for any of this now that we have the workflows and the species data at our fingertips.
Cool. All right, we have some questions from Emily Corwin. She asked, does the forest carbon stocks layer include above and below ground stocks for mangroves?
I think so. I'm not sure if so. It's the above ground carbon from habitable, then the soil carbon from soil grids. So I'm not sure if soil grids does take into account mangroves specifically. That's something I'll have to look at.
Yeah, so Patrick, there are better data sets for and like finer resolution data sets for mangroves that aren't, I think, included in SOC right now. But the extent of those products do extend into mangrove ecosystems. They just may be underestimating carbon.
Yeah, I think they are for soil grids. They're definitely underestimating.
Yeah.
Okay, and Marcelo, we're going to get to you in just a moment. Emily had one more question, which was, if we want to download the layers directly from the Sparc Visualizer, what is the best way to do that?
Oh, well, I can answer that. I can just turn on the downloads layer, and you'll be able to see that there. So it's just not turned on for this data layer. Patrick, I guess it's up to you too if all of these priority layers are available for download.
Yeah, I mean, they should be.
Okay. So it's just a matter of me turning that on the back end. So then just for clarification, Emily, this is an example of what the download button looks like. We can't turn it on for every layer in the Atlas just because of licensing and distribution under those licenses, but for things that we create, we can turn it on. So I'll turn that on for all layers that are shareable.
And Monica, just to follow up on that question, can you download, after you draw your shapefile, can you actually download that clipped version?
Yes, you can. So there is a button in the analysis tab. So with the caveat that we have to go through the process of tiling all the layers. So right now only the forest stock will work, but as we go through, we're going to start prioritizing which layers should be added, and then you will be able to download whatever you've drawn or selected from the country drop-down or uploaded as a GeoJSON. So that was a major issue with a lot of people who wanted to just get a little snapshot of an area of interest for a global layer, and so we just added that under this development now.
Very cool.
Nice. All right, Marcelo, would you like to ask your question now?
Yeah, hi, thanks. Thanks, Patrick. This is really interesting. I have a question. It's a kind of a technical question, and it's regarding the data, the biodiversity data. Where did you get the data, or what kind of data did you use for the modeling, and what was the modeling technique that you used?
Oh boy. Okay, so for the plant data, we relied on the decade-long efforts of the BN group to provide us with comprehensive plant occurrence data across the tropics that's gone through their rigorous both taxonomic and geo-validation screening processes. In addition to what the BN folks had done, we recruited a couple other large data sets for tropical plants and fed that through the screening algorithms. Same thing for vertebrates. So a lot of those were obtained from either bird life, restricted range birds. We had a couple small projects to expand our data sets within a country. Had some good collaborators in South America to provide vertebrate data for South America. Again, those were screened for outliers, made sure they were geo-valid. So that's the species occurrence data. At least 3 different species modeling workflows were used. So the ones that we're showing here were produced with MaxSense, fit at 1 kilometer. So there's a model current range for all species, and again, we did this for 115,000 species globally, and then projected that forward for 2 future time steps, 2 RCPs, and 10 global climate models. So all of those get rolled into the zonation prioritization that you're seeing here. Mm-hmm. That's the short version. I'm happy to answer any questions.
No, I imagine it's probably take another whole webinar, but yeah, this is I was wondering if he had used like point locality data and species distribution models and then link it to
absolutely.
Yeah.
Yep.
Okay.
Yep.
Hi, this is Lori Katz. Are you able to hear me?
Yes.
Hi. I'm from the Center for Oceans and have a question for, I guess, both Patrick and Monica about, I see some data layers related to oceans, but curious how detailed those are and what applicability there is at this point for resilience in oceans and future plans. I know that there's an MSPARC in the works, but would love to get some insights on where this is headed.
Yeah, so we actually, before Eva left, Victor and I met with her to add some of the OHI, Ocean Health Index, layers to the Atlas. So everything that is available under that marine tab, under stressors and shocks, are the kind of layers she wanted to prioritize and add in. So those should just be the, I guess, the most recent layers. Some of them have 5 or 6 years of data. So we're trying to figure out how that should be designed, if it's important to have every year time step. But these were just added actually this past week. So I think we just wanted to add them and then revisit how the design looks and everything moving forward. So Victor and I are meeting this afternoon to figure that out. So as far as moving forward, I mean, we really just display as much data as we can here that, of course, we have the license to display, but also is relevant to this work. And we recently, of course, have always known that the oceans data sets in the Resilience Atlas were the most sparse. So we're very interested in adding more data sets. Of course, it will depend on the licensing. We may have to reach out to data providers if there is some restrictions on their licensing, but we're happy to work with the oceans team to add more data sets here as well. I don't know if Victor, you have anything to add?
No, I think that about covers it. And yeah, we'll have some more updates, I guess, after today's meeting.
Yeah, and Victor is being trained on how to add all these layers, so he also will have his own agency for adding things or creating Oceans Atlas in the future. So, and then
Fantastic.
I don't know if there's anything, Patrick, you would like to add about Marine Sparc?
Yeah, I mean, there's so it's in process in development, and just to make clear that what we're seeing right now, Sparc 1 was purely terrestrial, so it's just land.
So following up on that, what would kind of the process be for a program, be it, as Laura mentioned, Center for Oceans, but perhaps a country program or a project within CI, if they were interested in being a part of the Resilience Atlas? Do they just reach out to you, Monica, or how does that, and is there funding available for you to support whatever data sets they bring, or do they need to have some sort of funding to bring for paying the developers and such?
Yeah, so creating new atlases and within this kind of realm of functionality is free on our end. We do, of course, have to pay to host the data, which is a pretty low cost, but that's the only major recurring cost that we have. So the only thing is if it's a significant investment in time, we'd have to discuss how to cover my time or potentially train somebody on another team, which is something that we want to do moving forward. So I'm not like a complete bottleneck of adding new things. So Patrick will be trained, David Hunt will be trained, Victor will be trained, I think, within the next month. Of course, Alex knows because he was around for the original creation of the Atlas. But yeah, we're definitely open for collaboration. We think this is a very underutilized resource at CI, so you can always just email me directly and we can figure out the next steps.
So just a follow-up on that, because I was thinking about the FHI and anything related to freshwater. Mm-hmm. So is it a requirement to have like a more, the scale is like the globe, is like worldwide, or could we add layer for things that we have just few places around the globe?
Yeah, so we can do either way. If it's, if that data layer is only relevant at like a watershed level, we can display it, but we can also create an atlas at a watershed level and then have all the data layers clipped to that extent. So then you really have, especially because at a global scale, some of the resolution is very coarse that we have. So we can go either way. We just figure out what looks best, because if we have different layers, it may have to be like the country drop down where it has all these different kind of geographies. but if there's something that you need a full data atlas for a watershed, we could always, create an atlas for that and add all the data layers that would be relevant for people making decisions at that level.
So another question, I was hoping you could speak to what the user experience is like, be it kind of internal or external. It looks like the demos you showed us don't require a login. It's what the general public would see. Is there a different experience for someone when they log in?
Oh, yeah, I should have mentioned. So the login and register button are actually just the steps you have to do to download data layers. Okay. So if I try to, for example, just download this right now, because I'm not logged in, it'll just prompt you to do so. So then you'll have to create an account, and that's just because we track that on the back end. So nothing else in the actual design is different than just accessing layers.
And so any data that we'd want to be a part of it would be something that you would want to be publicly viewable versus like any confidential or internal information then.
Yeah, so we can create an atlas and have a password, and have it password protected for sensitive data sets. But usually if we don't want anything to be shared, or if the licensing doesn't allow free distribution, then we don't even turn on the download functionality. So there's different layers of protection that we can have with data layers within an atlas, or with access to an entire atlas if there's perhaps sensitive data that we don't want to share. But usually those passwords can be easily shared. So layers like the KBA layers, I've just never added because there's so much sensitivity around those data layers.
Thanks.
So do you have any kind of, thoughts to share on how, decision makers are using, or if they're using the Atlas at all, or kind of point out some specific examples where this was used?
Yeah, so I kind of alluded at the beginning about where we used it in Madagascar and South Africa for the ecosystem-based adaptation work. So essentially, I traveled with the policy team at CI. We were holding workshops to kind of introduce the idea of ecosystem-based adaptation, because these were the same stakeholders who were developing national adaptation plans. And we wanted EBA projects to be a part of that. And I mean, I think for most people in the Moore Center, this seems like a very simple tool. You just turn layers on and off, and this is something that we may have more exposure to than most folks who are used to engaging in maps. And the policy team designed a really interesting kind of activity. So first we broke down by regions in the country, and then we rearranged the groups using the atlas to like sectors, I guess. And people they took away different things based on how they were kind of organized, but also, I mean, everyone knew, okay, I work in the ag sector. I know that there's a drought in southern Madagascar that's impacting food security, but to actually be able to turn on those layers and see, okay, there's a drought because, yeah, there's decreasing rainfall in the past 30 years. There's also increasing temperatures in the past 30 years. And to be able to actually spatially visualize that was very, I guess the policy team said it was very eye-opening to people. So you'd see some people in the room who were like, this isn't that impressive, this is just a map. But then for folks who didn't have these sources at their fingertips, it was really kind of, a game changer as far as that policy forum where, we can talk about these things, but when you're actually looking at something that shows this is the actual change over time that we've been seeing, to explain why we're seeing those kinds of, impacts to food security, for example. So it is a very, I think, useful platform for kind of cross-cutting issues, for working with different stakeholders. A map is something that everyone can understand, more or less. So it's just a kind of a good way to form a discussion, and of course, if you're trying to discuss like something with somebody and you want to kind of, a lot of us will draw things. This is an easy way. You could just say, oh, I can just go to the Resilience Atlas, open the map, and start turning on and off layers so I can actually discuss, the particular context with somebody, whether it's a donor or another scientist or a policymaker. Everyone can understand a map when it's in front of you and you're talking about the context. So.
All right, any final questions? All right, well, thank you again, Patrick and Monica. It's great to see this example of bringing different data sets together to bring new insight and information to a variety of people. And I appreciate you guys being willing to present it when it's so almost hot off the presses. So thank you guys and good luck with the final stretch. Again, this recording will be made available through our GIS CI video channel, and I'll send out that link to everyone later today. And if you have suggestions for future webinars, I know Patrick just mentioned Sparc would be an entire one in itself, but please do let me know. And with that, have a great day. Stop the recording.
Thanks, everybody.
What do I just try to hit pause and I can take it from there.